So hello everyone, this is lecture 29 for the lecture in magnetism. From the today onwards, we will start the application part. So first we will see about the electromagnetic waves. So first we will study them in the free space, then we will study in them the dielectric medium and all. So let's see. In the free space, the rho charge density will be 0 and current will be 0, current density. And this epsilon will be equal to epsilon naught, mu will be equal to mu naught because mu r and mu epsilon r will be 1. So this is the case for the free space. Now the Maxwell equation in this case will be divergence of E will be 0 because this is equal to rho by epsilon naught and rho is 0, so this will be 0. Divergence of B is 0, del cross E equal to minus del B by del D, and del cross B is equal to mu naught epsilon naught del E by del D, because here the free current is 0. So only electric field is changing. So this is the case for the free space. Now using this we have to write the electromagnetic waves equation. So normally we know any wave can be represented by this equation. So del square f equal to 1 upon v square del square f by del t square, where f is the amplitude changing, is how the amplitude is changing, v is the speed at which the wave is traveling, and t is the time. So if we can write the magnetic field and the electric field in this way, so we can write the equation of the magnetic field or the electric field in the electromagnetic waves. So let's see how can we write. So take this equation, this third equation, and take the curl of this. It will give you curl of del cross E equal to minus del by del t in curl of B. So from here this will be, means after solving this it will give you del dot E minus del square E. So this is the formula to solve this triple cross product. Now this will equal to this, and here it will go inside, means del cross B we can write from here mu naught epsilon naught del E by del T, and it is again del by del T, so it will be second order derivative del square E by del T square. Here this divergence of E is 0 from here, so only this term will be remaining, minus will cancel out, you will get del square E equal to mu naught epsilon naught del square E by del T square. And see, this is the equation of wave again, because here we can see in place of electric field, in place of F we have E, and in place of V we have mu naught E naught, means 1 upon mu naught E naught will give you 1 upon V square. So because you can just put the values of mu naught and epsilon naught, you will get 1 upon V square, and where V is nothing but c, speed of light. So you can check that, and similarly you can solve for B using this equation, take the curl, and you will get this equation del square B equal to mu naught epsilon naught del square B by del T square. So this is again the speed from here, this is equal to nothing but 1 upon V square. And now you can see that this electric field, and this is the wave of electric field, this is the wave of magnetic field, and speed is nothing but 1 upon mu naught epsilon naught under root. So just all these values you will get the speed, and that is nothing but the speed of light. So now see, this is the equation of waves, we have the speed. Now what the differential equations are made here, these are the two differential equations, and we let's assume that wave is traveling in the z direction. So direction of propagation is z, and then we have these two equations, del square equal to, means in place of del square we can write just with the z, because this is traveling in z direction, so it will be del square of del z square. Same for B, del square B over del z square equal to mu naught epsilon del square by del t square, mu naught epsilon del square B by del t square. So now we have these two differential equations, we need to solve them to find the equation of wave. So to solve them we need what we need, so these few points you should remember that we need them to solve the differential equation. So E naught amplitude we must know, and lambda frequency and the angular frequency, where f is nothing but c by lambda, angular frequency is 2 pi f. We should know wave vector, this is nothing but propagation vector, that is in the direction of the propagation. K is kz cap, k is 2 pi by lambda. We should know direction of propagation, we should know the phase and the phase constant. Then we must know the direction of polarization. So what is the polarization? Polarization will be in the direction of electric field. So that's how you can just analyze that. So if we know all these things, then we can write the electric field as, it is traveling the z direction, so it will be E z t equal to E naught cos kz minus omega t plus delta x cap. So here this represents the direction of polarization, so it will be in the direction of x cap, means electric field, the magnitude of electric field will be changing in the x cap direction, and the wave is traveling in the z direction. So this is how this equation is solved. So this is nothing but, this complete is called the phase, and this delta is called the phase constant. And similarly we can write for the B also, bz t equal to B naught cos kz minus omega t plus delta. So this y cap represents that B, the amplitude of B is changing in the y direction. And now we can just represent this in this, means we can see that electric field is changing in the x cap direction. So electric will be in this way, means amplitude is changing in the x cap direction and wave is traveling in the z direction. So this will be your electric field. And for the magnetic field it is changing in the y cap direction, so it will be in this way and traveling in the z cap direction. So your magnetic field will be in the yz plane and your electric field will be in the xz plane. And how you can identify that the wave is traveling in the plus z direction or the minus z direction? So wherever you will get 1 plus and 1 minus kz minus omega t or omega t minus kz, then you will see that wave is traveling in the plus z direction. But when you will get minus kz minus omega t or kz plus omega t, then you will say that wave is traveling in the negative direction. So you must remember this to identify the direction. And this is called the transverse of electromagnetic mode. Why? Because here we can see that the component of electric field or the magnetic field along the z is 0. So that's why this is called a transverse, and we know about the transverse, that is perpendicular. So now what are the properties of this? And this is also called the plane wave solution. What is the meaning of plane wave? Means if you take any plane at any point of z parallel to xy plane, then the value of b and e at that point will be equal. Means they will change with the z, but at that particular plane the electric field and the magnetic field will be equal. So you can take plane here, so that will be give you same value. You can take plane here, that will give you same value for the electric and the magnetic field. That's why we call that plane wave solution. Now the properties are E and B both propagates with same speed c. So both are propagating in the direction of z with the same speed c. There is no phase delay between A and B, so they are in the same phase and there is no phase delay. So you know what is the phase? That is initially at what angle they are traveling. So they are initially at the same phase, and at all points they will be in the same phase. EM waves are transverse in nature, so these are the transverse. They are perpendicular to the z direction. That's why we can say that they are transversal. So the propagation direction k cap dot, this is the polarization direction, n cap, that is means in which way the amplitude is changing. So that both direction will be perpendicular to each other, and that will give you 0. So see, this is perpendicular to k and this is also perpendicular to k. So that's why we'll get 0 it always. And for longitudinal waves, we know k dot n cap is not 0 because there the amplitude is changing along the direction of the propagation. So there they are not perpendicular. So now if you need to find the b naught and you know e naught, so you can just find 1 upon c e naught, and same you can find the e naught also from the b naught. So you must remember this relation. So these are the properties. Now we must know what is Poynting vector. So the formula for the Poynting vector is represented by s cap. S vector is equal to 1 upon mu naught E cross B. So it is from E cross B, you can see it is in the direction of the propagation. But what this represents is, it represents the energy per unit time per unit area transported by the field. So this electromagnetic waves carry some energy, and it is carrying energy, and the energy per unit time per unit area is called the Poynting vector. So that represents the Poynting vector, that what is the energy per unit time and per unit area. So energy per unit time is nothing but power, and per unit area represent the intensity. So ultimately this S representing the intensity, that is power per unit area, and we also call it as energy flux density. And if you need to find the energy flux, so that is just to integrate for the particular area, you will get the energy. So that is energy flux, you will get an energy flux. That means you will get the power actually. So S represents direction of the energy flow, and we can see that E cross B will give you direction in the parallel of k cap. So the S will be in the parallel of k cap, means this is nothing but S is parallel to the direction of propagation. S is parallel to k. So you must remember these things about the Poynting vector. Now we can find B, means using this formula 1 upon c k cross e, k cap cross e, and we know what is c here. C is omega by k, and c is omega by k, you must know. And if you put the c equal to omega by k, then k and k cap will give you the k vector. So that will give you b equal to 1 upon omega k cross e. So you must remember these formulas. If electric field is given, you can find the b, and if b is given, then you can find e using this formula k cap cross b, and k cap is nothing but direction of propagation, unit vector along the direction of propagation. So you must remember these formulas, they are very useful. Now up to now we were studying that means the propagation in the particular direction z, x, y, or x, y, or z. But if direction of propagation is some arbitrary direction, that is k vector, then how can we find the things? So how can we write the equations? So ERT, now this time we represent it as R is some x, y, z, anywhere it can be. That will be equal to E naught cos k dot R minus omega t plus delta n cap. So this is a general equation, and where R is nothing but x x cap, y cap, z cap. Now see that if your k is in the direction of z only, so it is propagating in the z direction only, then it will be k z cap. So it will give you only, when you do the dot product k dot R, it will give you k z. all other terms will be 0. So you will get ultimately the same equation what we discussed, kz minus omega t plus delta. So that's how you can write a general equation. You must remember this. Now there is a way we can write our means this wave equation in the form of complex, means a complex wave equation we can write. And what is the use of writing the wave equation in the complex form? Because in the complex form we will get some exponential term, and exponential terms are easy to solve in the differentiation and the integration form. So that's why we can write this into the complex form, and that will be easy to solve in the mathematical way. So if we can write E z t, this is the complex E equal to E naught exponential I kz minus omega t plus delta x cap. Now this is nothing but exponential I theta will give you cos theta plus I sin theta. So see, the real part will give you the same wave equation, this equation cos theta. So the only thing matter to us is real part from here. So we can write this in the complex form, and the only real part will give you original wave, that is real part of the complex E. So that will give you original wave. You must remember this thing, and we are writing this because this is very helpful in solving the mathematical problems very easily in the differentiation and the integration. And now we can write, means we can take just delta outside, it will be exponential I delta and exponential I kz minus omega t. So we can write this whole term. This is again complex, so it will be means E naught complex equal to E naught exponential I delta. So this equation can be written in the complex form as E naught complex exponential I kz minus omega t x cap. Similarly we can write B also in the terms of complex, it will be B naught complex exponential I kz minus omega t y cap. And in the general form, the RT form will be k dot r minus omega t n cap, where n cap is the direction of polarization. So must remember all the time that the real part will give you the original wave always. And BRT can be find it here 1 upon omega k cross ERT. So this is the general formula, we already discussed this here. So that's how you can find the things. Now let's discuss some questions based on the electromagnetic waves. Then you will understand these things more. First, write down the electric and the magnetic fields for a plane monochromatic wave of amplitude E naught, frequency omega and phase angle 0. So these are the things given, phase angle is 0 and frequency omega, and E naught is the amplitude. We need to write the electric and the magnetic field. So E and B we need to write. So first, the case is traveling in the y direction, so wave is traveling in the y direction, polarized in the x direction. So if it is polarized in the x direction, then electric field direction will be the same as the polarization. So electric field will be in the x cap direction, and this y direction is the propagation angle. So k equal to omega by c. So E will be equal to E naught cos, and here is the direction of propagation is y. So omega by c y minus omega t plus phase angle is 0, and direction of polarization is x cap. So E will be this. So now we have E. So for the first case we have E. So we can find the B also using the formula. So B is nothing but 1 upon c k cap cross E, and k cap is nothing but in the direction of the y cap, so it will be y cap, and E we already find this. So E is this, so it is just some in direction of x cap, so it is some value, and the x cap, so y cross x will give you z cap, and the minus z cap it will give you. So you can see from the coordinate system x, y, z, so y cross z will give you minus, sorry, y cross x will give you minus z. So B will be in the minus z cap direction. So this is the first case. Now the second case is the wave is traveling in the direction from the origin to the point, means the wave is traveling now in the arbitrary direction, that is to the point 1 1 1 from the origin, with polarization parallel to the xy plane. So this time polarization is parallel to the xy plane, and wave is traveling along the 1 1 1 direction. So wave is traveling like this from the 0 0 origin to 1 1 1, and the polarization is along the xy plane. So we need to find the electric and the magnetic field now. So see, first we need to find the k vector, means what is the k vector. So k vector is equal to omega by c and the direction k cap, and k cap is along the this vector, and we can find this unit vector along this is 1 minus 0 1 minus 0 1 minus 0, so it will be x cap y cap z cap. So unit vector along with that will be 1 upon root 3 1 upon root 3 1 upon root 3 x cap y cap z cap, because this magnitude will give you 1, and this is nothing but r cap along the this direction, and this r cap equal to k cap. So k vector will be omega by c and r cap is k cap here. So k cap is we just find the unit vector using these values. So this is your k vector, and r is some any x cap, and y cap z cap. So in general form we can write k dot r will be omega by root 3 c x plus y plus z using the dot product. Now electric field is given by, so we are using the this general formula, this one. So now electric field will be E naught cos k dot r minus omega t plus delta. So delta is already given 0, and this k dot r we just find it, so it will be this minus omega t n cap. Now this is the direction of polarization. So this is given in the xy plane. So let's assume in the xy plane we have some n cap, that is alpha x cap plus beta y cap. So we need to find the value of alpha and beta. So to find that, we know the conditions. First, the magnitude should be 1, and second, that k dot n cap 0. K dot n cap must be 0, means direction of polarization, and direction of propagation must be 0, means they should be perpendicular to each other, so that will give you 0. So k we already find it, that is this. So k dot n cap, just do the dot product of this and this. So it will be alpha plus beta equal to 0. When you do the dot product, this will give you alpha plus beta equal to 0. So alpha will be minus beta. So just substitute here in place of beta minus alpha, and it is alpha. So alpha x cap minus y cap will be your n cap. Now to find the alpha, so we will put the second condition, that is magnitude must be 1. So magnitude putting equal to 1, that will give you alpha equal to 1 upon root 2. And now alpha is 1 upon root 2. So your n cap will be 1 upon root 2 x cap minus 1 upon root 2 y cap. So this is your n cap. So electric field will be, just in place of n cap we will write this. So we'll get our electric field. So this is your electric field. Now to find a B, that is magnetic field, that will be 1 upon omega k cross E. So k is this, it is direction, and this is your k, and E we just find it. So we need to do the cross product. So again the cross product, we will see that it is cross product like x cap, y cap, z cap, and all the magnitudes of k and all the E. So see, in the k case, we will see, if you take the omega by root 3c common, it will be 1 x cap, 1 y cap, 1 z cap. So you will write omega by root 3c in the all form, omega by root 3c, omega by root 3c, omega by root 3c. So you must take omega by root 3c common, so it will be here. And this wave, it is 1 upon root 2, and this common term will be multiplied with x cap and y cap. So we'll take this thing common, that will be 1, and minus 1, 0 will be remaining in the coefficients. So we can write our determinant in this form, 1 minus 1, 0. So we just take these terms common. This then multiply with this, you will get this here, and this multiply with in all these three, you will get the same thing. So we can take these things common, and this will be your determinant then. And after solving this, you will get your magnetic field, that will be in this x cap plus y cap minus 2z cap. So this is your magnetic field, this is your electric field. So that's how you can solve the general case. So in the next lecture, we'll see the energy density, and we will see how the electromagnetic waves travels in the dielectric medium and the magnetic material. So that's all for today. Thank you everyone.